Welcome to the second part of the random maze generator tutorial. In the last part, we showed how to create a grid with the walls of the maze and how to set the first cell from where we will create random corridors of the maze. In today's video we will create instructions for checking neighboring cells with raycast, selecting a random cell, moving the current cell to the next cell, and finally we will get to the backtracker instruction. I decided to check neighboring cells with the help of raycast, but you can choose another way, for example calculating the index. Remember that almost every script can be done in at least two ways. I thought about whether I should also make a graphic representation of how it all works, but I think that those who are really interested would be able to find videos from other sources, or I can send you such videos, and here I will devote myself exclusively to creation in the Ylands editor. So let's continue scripting our maze generator. Let's open a global storage in which we already have a script for creating a grid, and create an instruction with the name, check neighbors. In this instruction we insert 4 local variables and name them according to the names of the cell walls, that means, up, down, left and right. Insert vector tile vector plus vector into each variable. In place of the first vector, we insert a tile get position entity. And as an entity we insert our global variable current cell. In the position of the second vector, we insert a tile of individual vectors. We will gradually insert another global variable named offset into this tile. For each type of variable, we will also add a minus number tile to the offset. In these variables, we also adjust the value of y in the individual vectors. This will represent positions directly above the center of neighboring cells for the current cell. We will direct raycast from these positions. Next, we add another local variable to the beginning of the instruction, but this time an array variable. Let's name it, for example, origin raycast. Let's leave it set as an empty array. Below the variables from the vectors we will add a series of tiles with the name set array. Let's set indices from 0 to 3. We put our variable in the array field, and we put variables with vectors in the object field. We insert another local variable array under these tiles. We name it, for example, possible neighbors. We will later insert an instruction into this variable that returns an array. But we have to create this instruction as soon as possible in order to get the calling tile for this instruction. We name the instruction detecting neighbors. We add an array value named positions origins to the instruction. After creating the instruction, we can insert the calling tile into the variable, and into this tile we insert the position origins variable. In this instruction we insert the array variable again and name it possible neighbors. We put the value of this variable in the return field of this instruction. Put a loop for each subject under the variable, and put the array value from the instruction into the array field. Insert the raycast vector tile into the loop tile. Be careful to use the correct tile. Do not use terrain raycast, because this tile cannot detect entities. In the first position of the raycast tile, we will insert the condition in which we will find out whether the affected entity is an entity label, and also what value of the visited variable this entity has. Then we just add the tile at last array to this condition. Now we will create another instruction which we will name choose random neighbor. In this instruction, we insert again the array value named neighbors. We insert the calling tile of this instruction into the check neighbors instruction. We insert a new local variable into the instruction and name it next cell. Into this variable we insert the tile getRandomObjectArray, and into this tile we insert the value from the instruction. Onto this variable we insert the attach label entity tile. As the entity we use the value of the next cell variable, and as the logic of the label we mark the next label. We can set a name for this label, for example stack. Again, we insert the variable called visited that we created in the entity storage, and we use the value of the next cell variable as the entity. We set the value of this variable to true. Another variable will be a global variable named current cell. Yes, this instruction selects a random cell from neighboring cells and creates the current cell from this random cell. To this instruction, we will create one more instruction for removing the walls of the maze between individual cells. The reason why I create so many instructions and do not do it in one script is simple. Overview. If we divide the script into several instructions, it is much simpler and you will find things much faster in it that you need to find, for example, for repair. In this instruction we will create two values, current cell and next cell. The position of the calling tile for this instruction is very important. We must place it above the variable in which we set the new current cell. We insert the local variable into the instruction and name it middle position. In this variable we insert the vector tile loop, in which we set the value of t to 0.5, this will return the position of the center between the two defined vectors. We define these vectors using the getPosition entity tile. Finally, we insert the vector tile vector plus vector into the variable, in which we set the y value to one building block, but this value depends on the size of the walls of your maze. we will add another local variable array to the instruction. And insert a vector tile into this tile again. This time it will be an overlap sphere tile. The radius value again depends on the size of the walls of your maze. In my case, I set a radius corresponding to one building block. Place a loop tile onto the variable, into which we will insert the value from the array variable. Insert the despawn entity tile into the loop tile, and use the object from the loop tile as the entity. Now we go back to the random neighbor selection instruction, in which we insert another time delay of at least 0.1 seconds. And into this tile we insert the call tile for the check neighbors instruction. This will create a loop for us. In order for this loop to work correctly, we still have to go back to the check neighbors instruction and insert the condition into it. In the condition, we will find out whether the current cell has free neighboring cells or not. Let's do it with the help of tiles to get the length of the array. As the last instruction, we will create a backtracker. In this instruction, we first insert the despawn entity tile, and as an entity in this tile, we insert the global variable current cell. We add another local variable to the instruction. We insert the getArray tile into this variable. As an array, we will use the getEntities label entity tile, and we will mark the label with the name stack. And as an index we will use the number tile 0 plus 0, which we will change to minus. In place of the first 0, we insert a tile to get the length of the array. We rewrite the type 0 to 1. This way we get the last index of the entity array with the name stacks. We will add the last variable. It will be a global variable set current cell. We will designate the first variable in this instruction as an entity. We will add a time delay with a time of 0.1 seconds, in which we will again insert the calling tile of the check neighbors instruction. Finally, we add a condition to the instruction in which we find out whether the length of the entity field with the name stack is greater than 0. In the else line of this condition, we insert the tile to write text into the console and enter. For example, done as the text. We put the calling tile for the backtracker instruction in the else line in the condition in the check neighbors instruction. Finally, we add the calling tile of the check neighbor's instruction to the second lever. Done. Now we just test our creation and play with the input values to create a large enough maze. I hope you liked this guide, and it was at least a little useful for you. Don't forget to leave a like under the video and a suggestion for next tutorials.